So in this video, we are going to recap time series forecasting. And so as a kind of reminder and recap, we studied four separate time series forecasting models, two for stationary series, moving average and simple exponential smoothing, one that captures both level and trend, so exponential smoothing with the trend, and one that captures seasonality, level, and trend, Winter's method. One thing to note is to remember that the f of t equations can forecast n periods from today. So we stop at the last piece of demand we have. We need d of t to capture our components. So we need d of t to capture L of t for moving average. That's true for simple exponential smoothing. We need d of t to capture L of t and t of t for exponential smoothing and trend. And similarly for LAT, TAT, and then the seasonal for Winter's method. And so we do that until we don't have any more observed data. So after today, we don't have any D of T's, right? And so that's when you start using these F of T equations. And one thing to point out is the step of picking an appropriate forecasting method is really crucial because whatever happens in the past is assumed to happen in the future. So in the past, if the only systematic component we had was L of t, meaning a level, then in the future, we assume it's the same going forward. And so you should be able to identify just based on the outputs of your forecast, what was the assumption for the inputs. And so if your forecast that comes out forever into the future is the same, you're using a stationary forecasting method. If you don't think that's appropriate, then likely you need to be using a different method that captures some other things that aren't happening. So that is one kind of high level takeaway. Another takeaway to not forget is like in R, when we implement stuff, we use SMA, it gives you L of t, not F of t. So remember the connection between if you get L of t, but I need F of t and things like that. So that's an important thing to think about. So a key thing with time series forecast is that the past is a good indicator of the future. So what we found in terms of patterns in the past, we're going to capture and maybe potentially adjust, but we're going to capture them in the future. If we didn't see them in the past, we don't expect to see them in the future. And so, you know, where have you seen that similar prediction assumption? I know lots of you are either looking for jobs or internships, and maybe you've gotten to an interview that's sometimes called behavioral interviews. And they usually go and say, tell me about a time where you worked on a team and tell me how that happened and what happened. So why are they asking you about that, right? They're hiring you for the future. Why do they care about the past? And that's because one of the principles of interviewing, and this is actually a theory from industrial and organizational psychology, is the best predictor of future behavior is past behavior. And so basically, they're using a time series forecast when they're asking you these questions. They're basically saying, tell me a time in the past. And if you did something in the past, we're going to assume that you'll be able to have similar performance into the future. And so, you know, you could think about when you go on these interviews, they're basically time series forecasts. All right, so my kind of thought question here is for both moving average and simple exponential smoothing, f of t plus n is equal to L of t. So the forecast, n periods from now, so assume now is t, is L of t. So if I want to forecast for period t, which value of L of t is appropriate to use? Is A the correct answer, B, or C? So the correct answer is B. B is the correct answer because this is basically algebra. So one of the things to note is I'm going to use n equals 1 here. So then if I substitute into this equation, I get f of t plus 1 is L of t. And if I need for f of t, then that's L of t minus 1. Okay. This might seem really simple. This is a key to your homework problem that asks you to write a for loop for the moving average one. And so you may want to review this as you do that part of your homework. All right, so in terms of time series, again, one of the assumptions in time series forecast is we're using past data to predict the future. Lots and lots of companies use time series. It's actually quite powerful in terms of predicting things. But there are also other models, and oftentimes they'll be used in conjunction with what's called causal models. So what if we knew something out in the world that influenced the thing we wanted to predict? So regression is an example of this. And so an example that could happen is we have really good forecasts for the weather now. And so we're able to use the weather to predict how many people will show up at my restaurant. And in fact, there's a whole company that does that. And 90% of table service restaurants say local weather conditions influences their sales and customer counts. And so they could take the weather forecast and use that to forecast demand. This is just one of many, many examples, and this is pretty common, using other things that cause influence on demand. The probably most simple way to do this would be simple linear regression models, which you've hopefully seen in your stat analysis class. The idea here is we're not using past data to predict the future. We're using independent variables to predict a dependent variable. So as my weather example, an independent variable could be the temperature, and my dependent variable could be how many people come to my restaurant. And so this is something we're not going to go into a ton of detail in this class, but you've hopefully seen in other classes. And I want to emphasize that this is a way to also do demand planning. And so the key thing that they do with a linear regression is they're basically trying to fit a linear line between the actual observed data, and then they take an error between that dot and that, and minimizing that squared difference. And so, simple linear regression provides an estimate of the population regression line. And so this is what we're trying to predict. In Excel, we can do this if you use data analysis and regression. In R, you can use a linear model function, so they're relatively easy to do. There's no exam questions or such about the methodology of this, but I think it's useful to comment at the end because this is a powerful way to do demand planning. And much more sophisticated causal models, a lot of machine learning, et cetera, can fit as well. The other, just to kind of quickly comment about forecasting in practice, forecasting is a really common core supply chain module in software. So like ERP, enterprise resource planning software, most of them have a forecasting module. As you can see in R, there's really powerful open source packages that you can now use to do this. This is sometimes, again, called demand planning. And oftentimes what the software does is it does a good job of matching the data that you would have in your software, in your enterprise resource planning or other types of software with demand planning. And so the power of a lot of these software modules, the methodologies are relatively simple usually, but it's the connecting the data with the decision making. One key thing that is subtle but actually important is to distinguish between demand and sales. So if you think about what companies usually have data about, they have data about sales. Did they make this sale? That could be different than demand. So if you've ever showed up to a store and you wanted to buy something but it wasn't there and you left, usually companies don't have a good record of that. Instead, they just have sales data. And so this is actually a huge field. How do I take sales data to estimate demand? And it's actually a quite complicated thing that you could think about probabilistically and some other sophisticated approaches. But keep that in mind. You usually have data that is sales, not demand, even though what we're trying to predict is demand. Another way to improve your forecasts in practice is to do what's called collaborative forecasts. So the idea here is to not have each separate echelon make their own forecast. So in my, complicated example here is you don't want, all of these separate distribution centers and all these different raw materials to make their own. Instead, you want to collaborate and make one together. And so the reason that is really beneficial is that sometimes a retailer may have a promotion. And if the supplier doesn't know that, then they can't capture that in their forecast, right? And so you should incorporate as much information as possible. Companies like Walmart and Procter & Gamble got really famous for doing this, and they can show that their errors are smaller by doing collaborative forecasting. The other reason why we started with forecasting in this class is that forecasts are an input to all the other decisions we're going to make in this class, and forecasting therefore is related to our other decisions. Okay, and so we're going to talk about aggregate models, how much resources we have, network design, where do we have locations, inventory models, etc. And the kind of key point is that when you think about forecast, if we can be more accurate, so when we think about these 80% and 95% kind of windows that come out of our R studio code, if we can shrink those, what that's doing is that's saying we have less variability in our demand. And so what we'll find out throughout this class is as you have more and more variability, you have to have more resources to have the same service level. And so if you have less variability, which means if you have a more accurate forecast, you can actually have less inventory, specifically safety stock, to meet a given customer service level. And so that's really powerful. And so if you want to think about why also forecasting is important, is it reduces variability. And if you've ever heard of Six Sigma, the whole point of Six Sigma is to reduce variability. One way to look for where to reduce variability is to improve your forecast. This is hard. It's hard to predict the future. You'll always have forecasts that are wrong, but if you can make them less wrong, that can be super powerful and can translate to really large savings in terms of performance in your supply chain. And that's because as you're making decisions, follow-on decisions, if you have less variability in what's going to happen, you can be more efficient with your resources. And we'll see that throughout the class many, many, many times. And because of this, demand forecasting is now not just time series. We're using machine learning and all different things. I'm not going to actually go through this video, but if you're interested in kind of the more machine learning data science stuff, there's definitely more sophisticated models than what we learned in this class. And so what I want you to take away is that we use relatively simple models. We can make them more complicated, but what's key is making sure you understand what the assumptions are doing so that in the future you understand what's going on, making sure you pick an appropriate model, making sure you can understand what's coming out, and making sure to know, even if you use a really, really sophisticated model, they will still be wrong. And so we still will have variability in our demand, and we need to take into account that variability as we make other decisions. My final kind of comment about forecasting is not just hard in supply chains. We as human beings are actually really bad at forecasting. And so forecasting in social science is, this is me standing here. And if I look in the past, if I look back, I could see that I have a lot of seasonality, a lot of variability in what's happening in my life, right? There's maybe ups and downs, whether this is professional success, happiness, well-being. Usually it's not like very steady. Usually if I look back on my life, it's like, okay, there's lots of stuff going on. What we do as humans, though, is we say in the future, wherever we are, we're going to be pretty flat. And so we're actually really bad at estimating the future. And so there's some kind of interesting articles about that if you're interested. And so, I'm just going to end on that to say forecasting is hard. It's hard for supply chains. It's hard for humans. But if we can do better at forecasting, we can be better at making decisions, which is pretty powerful. So I'm just going to end there. This is available in your slides, but in terms of studying for the exam, so exam 1 will have forecasting and aggregate planning on it. You should be able to do these things.